So this is my demo for the advanced game programming module. As you might see, I decided to implement a technique to simulate shadows. In particular, what I'm using in this demo is called shadow mapping. In brief, what this technique does is first render the scene from the light's point of view onto a map of depths, and then these will be used to determine what is in shadow and what is not. In a way, it makes sense, of course, that whatever the light doesn't see has to be in shadow, as something like an object is obstructing the light itself. In this demo, the depth map itself is a texture, which in my case I have also rendered to a quad to be able to check it has been rendered correctly. Here it is. I can toggle it on and off with the J and K keys, and you can see it's the same scene as seen from the light's point of view. I can move the light, and so will the shadows. Now on my machine I see this depth map as red, and that might vary. You might see it as black and white, but it's not really an issue. It's likely because of the sampling of the depth map is done in fact on the red or X component or channel. Now the determination of the shadow themselves from the depth map is done in the fragment sheet, and it's fairly simple in theory. For each fragment you take the distance between it and the light and compare it with the corresponding value in the depth map. If you were to determine that the depth map value is closer than this fragment, then you can conclude that said fragment is in fact being shadowed by something else. And that is the general overhaul of this method. Of course, there are some issues that I've had to resolve. For example, one of the shadow acne, as you can see here, which is caused by the fact that the light and consequentially the depth map are tilted, making it so some fragments might be considered incorrectly shadowed because they might be in fact considered below the surface. The easy way to fix this was to add a bias, which usually move the surface a small amount to prevent this. You might notice that the shadow acne is still present in smaller quantities on objects with a steep angle like this rotating cube. And there are minor fixes for this, but it mostly comes down to finding a good compromise between a bias that eliminates all acne and one that creates other issues, such as the one of Peter panning. As you might see, some of the shadows seem slightly detached from their casters, hence Peter panning. And this is of course because of the bias we have set. There are minor fixes for it, like enabling the front cold face, as I have done in this tutorial, but in the end, as I said, it's mostly a compromise between the two, and it varies depending on the scene. Lastly, a thing to note is that I have applied some percentage cost filtering to soften the shadows, which is what you see here. The shadows themselves are not very well defined because of the limited resolution of the depth map, so we either increase that or, as I said, soften these shadows by averaging the shadow value of a texel with the one of the adjacent ones.